An easy section. We'll fly through this. So it's all about complex numbers. Now, you know what complex numbers are, right? You remember those from your algebra days? Let me review those real quick. So this is 5.1. What's the square root of 9? We're starting easy. 3. Yes, you got a uniform answer on that one. Good. Yeah, now, what if a young child asked you, why? Why is the square root of 9 3? What would you say? Yeah, 2 3s to make 9. Yeah, 3 times 3 is 9. That's the why. Or you might just say, why are you asking me such a weird question, you little weird kid? Get out of here. No. 3 times 3 is 9, right? Yeah, so square root, you're right on the money. Ask the question, what times itself is this thing? Like, so square root of 25, we say, what times itself is 25? 5. Right, okay. Now, with that correct thought in mind, let me ask you, what's the square root of, like, negative 25? Yeah, there isn't one. Because remember the question. What's the question? What times itself? Let me write it out. Maybe if I write in words, that'll help. What times itself, right? We just all agreed that we would tell the little kid, if we were in a good mood, the real answer. What times itself is this thing? Right? That's what square roots ask. So, right, what times itself is 9? 3. What times itself is 25? 5. So what times itself, its very self, is negative 25? Nothing. Right? You can't have 5 times 5. That would be positive. You can't have 2 negatives, because 2 negatives would also be positive. You think, yeah, okay, we'll just do 1 negative, 1 positive. But that's not times itself. That's times its opposite. That's not what square roots ask, right? That's not the very meaning of a square root. We agreed, right? Square root says what times its very self? Is negative 25? Nothing. Yeah. 5.1?
Because my 5.1 showing something totally different.
Well, no, we'll get there. I'm building up.
Oh, okay.
I'm getting there. Yeah. So square root of negative 25 is not real, is it? There's no number times itself that's negative, and that wouldn't, and same thing with negative 9. What's the square root of negative 9? What times itself is negative 9? Nothing. In fact, whenever you have the square root of a negative, it's not real. How could any number times itself come out negative? 2 negatives go back to positive, and of course 2 positives are positive. There's no way to do that. There's no real number that can do that. So what do? We use our imagination. Right? I'm not saying something you don't know about already, am I? Intermediate algebra. It's a prerequisite for this class. You know that. Well, so what is the square root of negative 9? We say, yeah, there's no real number. Nothing times itself is really negative 9. So let's use our imagination. Yeah, we say, well, if it wasn't for that negative there, it would be 3, right? 3 times 3 is 9. We go, but that negative's there, so we'll say it's 3 imaginary units. I'm not kidding. That is the answer, right? You know that, right? It's 3i. That's what that I means. Imaginary. Not real, like having an imaginary friend, right? It's an imaginary number. Can you believe this? What is going on here? I thought math was real. I mean, what in the world are we doing? Yeah, how about those statements I just made? I want to make sure let's be philosophical for 30 seconds here. Is math real? Yeah, right. You've heard me say it enough times. No, it's not real. None of it's real, right? Right? If I did my whole thing with if I saw 3 on the way to class with you, right? No, did I do that? If I saw 3. I saw math. It's real. I saw it on the way to class. 3. There it was. Just 3. You'd be like, what do you mean? You saw 3 people or 3 cars? No. Not 3 people or 3 cars or 3 objects of any kind. Just 3. Just the math. You'd go, what? What do you mean, Mr. Aaron? You saw like 3 spray painted on the wall or the number 3? I mean, what do you mean? No, I didn't see the number 3 written anywhere, spray painted on the wall or 3 objects. I just saw 3. I'm ready for the rubber room, right? You cannot taste, touch, or smell math. It's not real, is it? 3 is just an idea. It's all just in your head. What are we doing here? Class over, right? All of this math is just in our heads. It's all made up. Right, that's true. But it's made up for a purpose. It's made up to describe things that are real. If I saw 3 cars in a head-on collision in McKinley and Blackstone this morning, I came to class and say, there's these 3 cars. They're in a head-on collision in McKinley and Blackstone in the corner there. You know the concept of threeness. I know the concept of threeness, so we can talk about things in the real world that involve that concept, right? So math is made up to describe things that are real. That's how, and we saw that with the physics examples, right? That's a real wagon. There's real whatevers. I mean, real things are moved, and there's energy and work and things that are real in the world. And math is numbers put to reality to help us deal with reality. All right, with all that said, are imaginary numbers made up? Yeah, but so's all of math. Let's don't freak out. We've been making it up from the beginning. This isn't the first time. It's all made up. Not just the imaginary numbers. All the numbers are imaginary. Tell me one that's real. Tell me one you can taste, touch, or smell. Right? So they're all imaginary. These are especially imaginary, though. These are extra imaginary. All right. Having said all that, is there a real-life application of imaginary numbers? Is there something real you can do with imaginary numbers? They made it up to do real-life things. Okay, so now what they're going to want to do is they're going to want to take real-life numbers like 7, even though, what's up? Oh, thank you. Even though, 7, so 7, and so we take a real-life number like 7. You can have 7 coins in your pocket. And then we want to put it together with imaginary. So I want to take the real-life numbers like 7, and grab you can't have 3 coins in your pocket, but you can have 7 coins. I want to put them together. So this is real, this is imaginary, and when you put the real together with the imaginary and make up a new thing, that new thing is called a complex number, because it's complex. It's got 2 parts to it. It's got a real part and an imaginary part. So that's what this chapter is all about. So I was just doing an intro about what this chapter is all about. It's about complex numbers, which have a real part and an imaginary part. That's what's actually super useful in all kinds of applications. And the reason is because it's got dual parts. It's got 2 parts to it. And so that's very useful, like when you do the alternating current that's coming out of the wall. That has both current and amperage. It's got voltage and it's got amperage. And so anytime something in the real world has 2 parts to it that you want to, but it's still kind of one, like the current coming out is one current, but it has its charge and its voltage. It has both things. Amperage and voltage has 2 different things. And so anytime you have something in real life that has 2 aspects to it, it's very useful to use complex numbers because they have the real part and the imaginary part. Even though that's just made up, you let one part be the current, you let the other part be the voltage, and then you can do what you need to do in real life applications. It just keeps them separate, and yet they're one. That's why it's used, how it's used. So all right. So we've made up this new thing. Literally, they made up this new thing called complex numbers. It's a whole new world now called complex numbers. And with these numbers, we're going to define the rules. They did make up the rules for adding these things, subtracting 2 complex numbers, multiplying 2 complex numbers, and dividing 2 complex numbers. That's what this section is all about. So let's go back to it. Here we are, adding 2 complex numbers. How do you take one complex number, 8 minus 5i, and another complex number, 7 plus 3? They're both complex, right? They both have a real part and an imaginary part, and add them together. How do you add 2 complex numbers? Yeah, how would you make it up? Now, they made it up. How would you make it up? How would you make it up? Combine like terms. Exactly. That's exactly what. This is going to be supernatural. This isn't, it almost sounded supernatural. This is going to be very natural. It's exactly what you would think. It's not going to be supernatural. All right. 8 plus 7. 8 plus 7, 15. You just add the real part with the real part. The imaginary part with minus 5i plus 3i. Yes, I'll just make that minus 2i. Done. There it is. Just add the real with the real, the imaginary with the imaginary. Just like terms. Exactly. Totally what you would do. Want to try number 2 there? Can you read that? Yeah. So try number 2. Minus in front of parentheses, distribute. Don't forget to distribute. Then just combine like terms. That's all it is. So that minus sign distributes. And this minus sign distributes. And so we get 6, what is it, plus 8 minus 3i plus 7 plus I. Is that good so far? And then just, the real 6 and 8, 14 and 7, what's that, 21? And then minus 3i plus really 1i, huh? Is minus 2i. And we're done? That good? 21 minus 2i? So we added up a bunch of complex numbers and got another complex number. So we're in this new world of complex numbers. Adding and subtracting. There's adding, there's subtracting. Next we go to multiplying. If you're okay, I'll go to fresh screen, make that a little bigger. We good there? Good to go. So multiply. Now that's timesing, right? 9i is going to multiply that other complex number, 9 minus 6i. Go ahead and times those. Just do what comes natural. I realize I haven't told you the rules, but it's pretty natural. So boom, boom. So what do you think? What is 9i times 9? 81i. Yep. 81i. Minus, what's 9i times 6i? 54, right, you know something already. I squared. So far, so good. We're going to do a special thing which you're not aware of. But I think that part's natural so far. That makes it just like it's an X or something. Now, this is not like the dot product, by the way. And it can be confusing because we just did I's and J's for vectors. These I's are not those I's. Do you see that? Let me pause for a minute. We just finished chapter 4. In that chapter 4, I meant sideways movement. J meant up-down movement, didn't it? Vectors. I, J. Sideways, up and down. Now, chapter 5, we're in a different world. We're talking about complex numbers. And I is not sideways movement. It's not a vector. It's imaginary. See the difference? I means something different in this chapter than it meant in the last chapter. And it's going to all be there together in the final. You got to discern out what I means in the context. All right, so far so good though? So notice I'm not doing dot product here. I'm not dropping the I's and J's. That was a special thing called the dot product. Here I'm just going, look, 9i times 9 is 81i. 6 times I, 54. I times I squared. Good so far? I got one more step. That's not the final answer. Presley? We good? All right. So now the question is, what's I squared? What is I squared? It's got this weird I squared thing. Negative 1? How do you know?
We use I, the square root because of a negative, so 2 negative.
Yeah, right. Yeah, let me with you come up with, I don't want to just tell you, boom, here's what it is, but I want to show you with logic. So let's go back to what we were doing. What is the square root of negative 9 again? Let's go back to that. 3i. We good so far? Because what you do is you just square root the 9, 3, and if it's got a negative inside, that just throws out an imaginary. That's an easy way to think about it, right? Negative in a root just kicks out an I. It's going to be imaginary. It's not going to be real. And square root of 9 is 3. Okay, great. True. What's the square root of negative 4? By that same logic. Yeah, just kick out the negative, out comes an I, and then square root of 4 is 2i. Beautiful. Okay? What's the square root of negative 1?
I.
Right, grab the negative, kick out the I, square root of 1 is 1. It's 1i or just I. So now we got our hands on I itself. What is I itself? I itself is square root of negative 1, isn't it? That's I itself. Okay, great. So what? Well, if I is the square root of negative 1, what am I trying to figure out here? What do I want to know back here? I squared. What is I squared? So how would I figure out what I squared is? Square both sides, right? We already know I is the root of negative 1. Square both sides. I squared equals, now what's the root of negative 1 squared? Negative 1. You with me? Because squares cancel roots, don't they? Right? That's not new. Is that news to you? Right? Like if you have square root of 7 squared. Those cancel, and it's just 7. Okay, it's good with that. Here, let me prove it to you. Square root of 7 squared is square root of 7 square root of 7, right? Squared means 2 of them, doesn't it? And what's square root of 7 square root of 7? Square root of 49. What's square root of 49? See, it's true. Squares cancel roots. They're the opposites of each other. So the shortcut is just cancel 7. You with me? Does that make sense? Right? A 2 power and a root are opposites. They eliminate each other. We see the truth of it right here. 2 means 2 of them, and root 7 is root. Sorry, that looks like a fraction or something. I'm not meaning fraction there. Equals is what I mean. Square root of 49, 7 times 7 is 7. So see how it's true? It cancels the root. So same thing here. The root and the 2 power cancel. I squared is negative 1. Now hold on. Think about that for a minute. That's a real number. You can be in Minnesota in February and have a negative 1 temperature. I squared. You can say, yeah, I'm in Minnesota, and the temperature is I squared today. That'd be a weird way to talk, but that could be. You can have your bank account. I've been there. Negative, right? It's called being in debt, right? My bank account is in the I squared regions today, right? Negative. So my point is, I itself is crazy and imaginary, and you can't have that. You can't have your bank account be I. That's not a real number. But you can have your bank account be I squared. Do you see that I squared came back into the real world? It's kind of weird, huh? I is imaginary. I squared came back in the real world. So what? Well, that means anytime we see I squared, we're not going to leave it. It's just a real life negative 1. Pop in the negative 1. I's, on the other hand, we'll just leave them. They're weird and strange and imaginary. We'll leave I as I. But I squared, we'll say, hey, that's a real number. That's just negative 1. Put it in there. So that's what we'll do. We'll never leave I squared. So right here, we never leave I squared, but put in negative 1. Put in negative 1. So what do we get? We get 81I minus 54. And what's I squared? Negative 1. You guys with me? So I just put right in that I squared spot, negative 1. And so what is that? 81I plus 54. There we go. Oh, they want you to put the real part first and then the imaginary. See how they're saying, write it in the form A plus BI. Real part first, then imaginary. So they want you to actually say 54 plus 81I. There we go. We good? So anytime I squared shows up, put in negative 1. We never leave I squared. We leave regular I, but we never leave I squared.
Is it going to be like a divided one, or is it?
We'll get there. Yeah. So want to try number 4? Let's do a few more multiplications. Yeah. Then we'll divide. It's the only other operation we have left. So we're learning to add, subtract, multiply, and divide these new things called complex numbers. So multiply on number 4 those complex numbers.
Do you foil it or do you?
Yeah, just FOIL. Yeah, it's not good question. It's not the dot product, right? This is regular FOIL. This is not dot. These aren't vectors. Yeah, good question. Just do the normal FOIL. Normal FOIL. First to both, second to both. 4 multiplications, yes. Because these are not vectors. It's not IJ. It's complex numbers. It's not dot product. It's regular product. Okay, so to do this product, it's just a normal FOIL. It's not a dot product. These are not vectors. Boom, boom. 6 times 7, 42 minus 35i. And boom, boom. Minus 18i plus 15i squared. So far, so good? First to both, second to both? Combine like terms. So 42, the 2 in the middle, what's that? Minus 53. I plus 15. And what is I squared? Yeah. So we get 42 minus 53i minus 15. Good so far. And then what's 42 minus 15? Oh, it is, thank you. 27 minus 53i, and we're done. Good enough? Nothing too amazing or difficult, right? Just like normal. We'll skip number 5. 5's the same thing. Let's get on to dividing. So we've added, subtracted, and multiplied these new creations called complex numbers, which have all kinds of real-life applications. Right, so how do you divide? Add, subtract, multiply, now divide two complex numbers. Well, it's actually a little bit interesting. This one will be a little different. Let me rewrite it a little bigger. What was it? 3 over 9 minus I? Okay, so what we're going to do is you want to remember, what was I itself? I squared was negative 1. What was I? Square root of negative 1, right? So my point in that is when you see that I, just think square root. Think square root right there. So let me ask you, what if somebody, I'll just pick up a number. What if somebody gave me 3 over 9 minus root 7, for example? Anybody remember from algebra what you do with that? It's called the conjugate. It's a special deal. So maybe I'm not being very helpful. If you don't remember from algebra, that's no help at all. So what you do is you use the opposite sign in the middle. Let me just write it out. So when there's I in the denominator and a plus or minus. So when you have I and a plus or minus sign, you multiply top and bottom by the exact denominator with opposite sign in the middle. Opposite sign in the middle, called the conjugate. So you take the fraction, you multiply top and bottom by exactly the denominator, but you put the opposite sign in the middle. So I'm going to multiply by 9 plus I over 9 plus I. Does that make sense? If the original denominator had 9 plus I would multiply top and bottom by 9 minus I. Make sense? This is what you do. So this is pretty different kind of thing. Really, it's exactly what you do in algebra when you have a root. That's what an I is. It's a root in the denominator. It's how you get rid of the root from the denominator. It's called the conjugate. All right, let's do it. So on the top, I'm going to multiply. 3 goes to both those. 3 times 9, 27, plus 3i. Good on the top so far. On the bottom, boom, boom. 9 times 9, 81, plus 9i, boom, boom. Minus 9i minus I squared. We good? So now what happens? Notice that these cancel. That's what we want to happen. That's why we did the opposite sign in the middle, to make that happen. Does everybody see that? That's why we did the opposite sign, so that would happen. Okay, so what does that give us? On the top, nothing has really happened, 27 plus 3i. On the bottom, this is going to be 81 minus, now I squared, what do we always do with I squared? We never leave I squared. That's negative 1. Huh. So that's just 82 down there, isn't it? Just going to be 27 plus 3i. This is my I. We leave I, but we never leave I squared. Plus 3i over 82. Yeah, and you can't reduce. But they do want you to separate them. That's just how they want you to type in the answer. If you type this into Math Excel, it won't be happy. And you want to make Math Excel happy. You live to make Math Excel happy, right? 27 over 82 plus 3 over 82i. You just have to separate. Just put the 82 under both of them and separate them. No big deal. There's our answer. Does that make sense? What did we do? We got rid of the I from the bottom. That's, see, remember the original problem had I in the denominator, was divided. Now it's just normal. So we divided. We effectively divided and have an answer that's a normal complex number. Let's try one of those. Questions? So before I move into one? Yeah, Austin.
Yeah, how come now the 81 just doesn't stay the same, it changes to 82? Because in the previous ones you had, on number 4, you had positive 15, and then the I squared got changed to, okay, I see, never mind.
We good?
Yes.
Yeah, right there. 15 times negative 1 made negative 15.
So it just changes the sign.
But here, yeah, negative and negative
Okay.
is just positive. Yeah, 2 negatives. That just becomes 81 plus 1.
Okay.
2 negatives there, so it's 82. All right. You know what to do. So you're going to multiply top and bottom by what? 4 plus 6i. Right? Same as denominator, but opposite sign in the middle, called the conjugate. So just multiply on the top, multiply on the bottom. Boom, boom. 12i plus 18i squared on the top. Good. Then do the bottom. $16 is 24i minus 24i minus 36i squared. That good so far? These cancel. That's exactly what always happens when you do the conjugate, the opposite sign. In the middle, you get those middle two I terms to drop out. That's why we do it. Next, we replace this I squared here and this I squared there. What do both those I squareds become? Negative 1. We never leave I squared. We leave regular I, but we never leave I squared. Those become negative 1. So we get 12i plus, and that's just going to make that minus 18. Can I just do that? It's just, I squared is just going to change the sign of whatever it's next to, because it's negative 1, huh? So plus 18i squared becomes minus 18, doesn't it? Everybody see that? And down below, 16, and then minus 36i squared will become plus 36, won't it? Because I squared is negative 1. So I squared just changes the sign. All right, and then can we do a little bit more? What is that? 12i minus 18 over, what is that? 52.
When you break it apart.
Yeah, then we can break it apart and simplify the two fractions, huh? All right, so we always got to say, now you got to put, well, here, let me first just 12i over 52 minus 18 over 52. Good so far? Then just reduce both those fractions. What's this? Divide by 2, top and bottom? Or 4?
The first one you could do 4, the second one you could reduce it.
Oh, yeah. Divide by 4, top and bottom would be 3/13 I. Yeah, and this one we can only divide by 2. 9/26. That's almost, so far so good? Now we just got to switch the order, because you got to put the real part in the front, the imaginary part at the back. Everybody see what we did there? Just reduce those fractions. Now remember, when you swap the order on things, whenever things move around, they take the sign in front of them on their left with them. That's their baby. So that negative is going with that 926 wherever he may go. So minus 926 plus 3/13 I. That's the fine. That's a complex number. We just divided two complex numbers and got a complex number answer. Is that good? Questions on that? It's all making sense using the conjugate? Yeah, exactly. Yeah. So take both those numbers. They want us to perform, write the result in standard forms. Yeah, change those both to I. Remember what we learned about square root of a negative? It's always, so whenever you have a negative in a root, just kick out an I. Remember that? So that negative right here, just kick out an I, and then just do the square root of 25, which is 5. So that'll be 5I minus, we good so far? So that's all you do. With a negative inside, you just say, well, that's not real, it's imaginary. Put an I, and then do the root. And then same thing here, minus, and then that negative, again, kicks out an I. And square root of 16? So 5I minus 4I, 1I, or just I. Done. Easy enough. Try number 9. I would first change this. First, what's the square root of negative 16? It's going to be 4I, isn't it? And then, what's the square mean? You got to write 2 parentheses and FOIL. So. All right, so this is going to be negative 4 plus 4I. Everybody with me on that? That negative in a root, again, kicks out an I. The square root of 16 is 4. And then the 2 power, right here, means you write 2 of them. You can't just square the pieces. That won't work. You have to write, whenever there's a 2 on a whole parenthesis, you have to write 2 parentheses. Take it from there. So write those 2 parentheses and multiply. Foil that out from there. We good, and then just go boom, boom. What's that going to be? 16 minus 16I, boom, boom, minus 16I plus 16I squared. Good so far? From the FOIL. Okay, and so this is what? 16 minus 16I minus 16I is minus 32I. Good. And what is 16I squared? Minus 16, because that I squared is negative 1. Right? And then 16 minus 16 cancels, and the final answer is just minus 32I. There's no real part left. It's all just imaginary. This good? Let's do one more. We good to there? Number 9. Am I rushing you? So let's try number 10. There it is on the board. Do this there on the screen. Do the same thing. So start with that negative inside that square root. Kick out an I.
Taking out an I never uses that sign, right? Until the end. That sign in the middle.
Yeah, never changes. Correct. Correct.
Well, until the end.
So taking out the negative doesn't change the sign. Yeah, it just makes an I. So then simplify that square root 18. Remember how to simplify a square root? Remember that from your algebra days? Or we did a little bit of it in here too, huh? Remember you got to break down the 18, 2 times 9, 3 times 3, 2 3s in, 1 3 out. Remember all that? Yes, exactly. Good. Okay, so, yeah, that negative in a root kicks out an I. We get negative 12 plus I root 18. And I'm going to go ahead and put them both. You know we need to separate it at some point, so I'm just going to separate it right now. The 60 is underneath each one separately. And now, yeah, for the 18, you just go 2 times 9, 3 times 3, 2 3s in. Remember how roots work? They're a 2-for-1 deal, right? Or you could just say square root of 2, square root of 9, and square root of 9 is 3. So it's going to be 3 root 2, right? So bring it on down here. We got negative 12 over 60, which we're going to reduce in a minute. And then this is going to be I, 3 root 2 over 60. Everybody good there? Because I simplified that root 18. It's 2 times 9. The root of 9 is 3. 3 root 2. Now, the 12 over 60, 12 actually goes into 60, huh? 5 times. So we get, notice what's that going to be? Negative 5 plus I 3 root 2 over 60.
Can you divide by the 3? And just leave it?
Oh, yeah, I forgot that. 3 goes into 60. What am I doing? You're totally right. I just kept thinking 3 doesn't go into 60. Of course it does. Yeah, thanks. We totally need to. We must. Yeah, 3 went into 60 20 times, huh?
Yeah, and the other one would be a negative 1 over 5, right?
Is that 5 wrong?
Yeah, because you got
Good, exactly. I see that mistake all the time, though. So I wanted to do it on purpose. I really do know better than that. So, right? Does everybody know, though? Because the 5's on the bottom, it can't suddenly pop up to the top like that. You guys are probably above that mistake. It's what I see in algebra students. There's our answer. All right, guys. We